this was initially called the Bitter Brews and Other Abominations, the Uses and Abuses of Some Little-Known Psychoactive Drugs, but I changed the title slightly because I wanted to focus on the potential uses of some of these little-known psychoactive drugs. So, plant chemistry represents an enormous sort of cornucopia of molecular diversity. What the drug discovery people call novel chemical entities. And in the drug discovery game, that's what you're trying to do, is find new structures that you might develop into new medicines. Sources of new medicines, sources of new research compounds, chemical molecular templates for the medicinal chemists to play with, precursors for semisynthetic chemicals, sources of all sorts of things, insecticides, herbicides, you name it. But our focus here is, of course, on pharmacology and on drugs. And we know that, again, these sort of big four, or these true hallucinogens, in the natural world, they fall roughly into four categories. Your phenethylamines, the mescaline-like compounds, LSD-like compounds, the ergot derivatives, the beta-carbolines, which are by and large not psychedelics, but they're important in oral potentiation. They're MAO inhibitors. Some of them are serotonin uptake inhibitors. There are a number of things. And of course, your tryptamines, of which there are many derivatives. And that's not surprising because dimethyltryptamine, the kind of primary one in secondary metabolism, is only 2 steps away from tryptophan, which is a universally distributed amino acid, one of the 20 amino acids that goes up to make proteins. So tryptophan is everywhere. It's in us, in everything living, because it's a component of proteins. And by 2 really very trivial chemical steps, it's converted to tryptamine, and then you can add a couple methyl groups on here, and there are enzymes in virtually all living systems that do this quite readily, and you get dimethyltryptamine. So DMT is 2 steps from primary metabolism. So it's not surprising that it's found in lots of things, plants, fungi, animals, including us. And then by further steps, you can get the various derivatives, most of which are psychoactive. Bufotenine, named after the toad, bufo, found in toad venom, but also in other mammals and in plants. Further modification, 5-methoxy-DMT, slightly different route. You get your psilocybin, psilocin, the so-called 4 substituted tryptamines. By cyclization of tryptamines, you get beta-carbolines by bringing the side chain around. So these are all sort of a family of tryptamines. They're all quite widespread, really, in the natural world. So, 2 steps. Just an example of how widespread these are. Here's a list of some plants that are known to contain DMT and some related compounds. These are the families over on the left, and the genera in the center, and in the parentheses is the number of species in these genera. So there are quite a number of species in most of these things. Chances are, if one species contains DMT, most of them do. So there are thousands, literally thousands of plants. And that was only the first half of the list, that contain DMT or its derivatives. This has created a conundrum for the regulatory authorities because, you're going to make all of these illegal. And if you are, how are you going to control that? And to tell you the truth, because tryptamine DMT is so close to primary metabolism, I have my suspicion. We know of about 200 species that contain DMT, but that's only because we've only looked at 200 species. I suspect there are thousands, and in my looser moments, or maybe more lucid moments, I speculate that DMT is probably found in every plant to some degree. if you were to go out and start sampling plants at random and run them through your gas chromatograph, mass spectrometer, or any other sufficiently sensitive instrument, you could probably pick up the molecular signature of DMT in just about any damn thing that you might pluck out of your garden or, take off the street. So this is a problem, really, for, how are you going to control this stuff? And should you control it, raises that issue. So, of course, with DMT, we get, again, a wonderful molecular template for the medicinal chemist to play with. And they work mainly, they do manipulations on the ring and on the side chain. And you get other things coming up that occur nowhere in nature as far as we know, but are certainly quite interesting, like 5-methoxy-N diisopropyl which has come to be known on the street as foxy-methoxy. And 5-methoxy-N diallyltryptamine. I don't think it has a street name, but give it time. We have our 4-hydroxy-N diisopropyltryptamines, a psilocin analog that also has interesting effects. And so in medicine, we also have some important substances that are really analogs of DMT, such as Pindalol, a beta blocker, which really evolved out of Albert Hofmann's work on psilocin. It doesn't look, but you can see the similarity in substitution in the indole ring. Or 5-methoxy-DMT has spawned sumatriptan, a very potent 5-HT1 agonist, another one of these serotonin subtypes that's the treatment of choice right now for migraine headaches, and this is on the market. So the study of these things does have an effect, does have a beneficial effect in discovery of new and good medications. Cacti, same thing. Most of us think of peyote or trichocereus as the sources of mescaline, but there's actually about 30 species of cacti that contain mescaline. And mescaline is not so widespread outside that family, unlike DMT, which is found in many families. It's not quite clear why that is, but what mescaline has done is suggest, again, to medicinal chemists like Dr. Shulgin here, one of the pioneers of studying the structure-activity relationships of psychedelics, and he initially started working with the mescaline skeleton and made many, many variations. And in my opinion, the man is a national treasure and should have gotten a Nobel Prize years ago. It's unlikely that he ever will. And this work, now is being continued by Dave Nichols. Dave Nichols kind of picked up the gauntlet and has extended this work and has had, by virtue of his position and interests and skills, has had access to these receptor systems and animal models and what have you. Shulgin was an independent pioneer that worked out of his lab, his own laboratory literally in his shed in his backyard, but still did wonderful work. And Dave Nichols has extended this greatly. So we have many, many phenethylamine derivatives as a result of their work and their colleagues' works. So why should we care? God, don't we have enough psychedelics? Why do we need more? Well, there are good reasons for studying it, because new structures can help us understand new pharmacological mechanisms, and new structures can lead to new cellular and molecular targets for these things, and that ties into this whole effort to make utilize these things as molecular probes for understanding consciousness, and as well as consciousness mental illness. And it can lead to therapeutic medications, and it can lead to the understanding of the human mind. And we all know this. I mean, I'm basically berating the obvious here. So that leads to the question: we know that that psychoactive molecules permeate the biosphere because of the molecular diversity that you find in nature, and the example of DMT, it's just all over the place. So what else is out there that might be interesting? Well, we're going to talk about that. Salvinorin A, again, I discussed it previously, so we don't have to dwell on it, but this has received attention recently, and it's achieved, it's become very valuable as a research tool for understanding the mechanisms of the kappa opiate receptors and how they affect altered states of consciousness. It may have therapeutic applications too, as example in depression, possibly in Alzheimer's, oddly enough. And it's this one that Brian Roth said he never would have discovered had he been looking for something. It was stumbled on by Mazatec shamans thousands of years ago, and took until quite recently for science to come along and elucidate what the active principle is and characterize its pharmacology. So Salvinorin A is a very good example of what the kind of thing we're looking for in nature. This is a receptor binding profile with the kappa opiate receptors. This is Salvinorin A. This is a whole bunch of different receptors down here. You can't really see that, but it doesn't matter. This one here is the kappa opiate receptor. As you can see, it doesn't bind to much else in this spectrum of about 50 different receptors. By comparison, LSD binds to quite a few different things. LSD is what the pharmacologists call a dirty drug. There's nothing dirty about it except that it has a low selectivity. It interacts mainly with the serotonin receptors, but also with a whole other sort of range of receptors, which may be partly responsible for its interesting potency and anomalies compared to things like DMT and psilocybin. So the fact that this is so selective and so potent, Salvinorin A being the most potent natural, psychoactive natural product so far discovered, makes it a great tool for studying the kappa opiate receptor dynamics and pharmacology. Another psychotropic mint, Salvinorin is a member of the mint family, is this one. It's received not very much attention at all. It's a Russian thing. It's native to Uzbekistan. And it contains another couple of terpenes, diterpenes, so they're relatives of Salvinorin A. They don't really look like Salvinorin A, but it's a psychoactive plant that's used by the people in Uzbekistan. It's kind of a commutative thing. It's not clear it's a psychedelic, or it may be more like a cannabis type drug. It's virtually unstudied. It's not even clear that this is the correct structure for these compounds. These were isolated in 1946, I believe, when they didn't have the tools that we have now for determining structure. So even this is a guess. It's interesting. It's hard to get a hold of the stuff, but it's worth investigating. Okay, so you've got Salvinorin A and this other close relative that are kind of examples of where this is going. So what else is out there that might be interesting? Well, how about fish? There are lots of fish, it turns out, that there are anecdotal reports about psychotropic fish, the so-called dream fish of the Norfolk Islands area. All of these different species have been reported to be psychedelic or psychoactive, at least. When you eat them, you have fantastic dreams, or you have acute effects while you're awake. Interesting area of unknown chemistry. There are reports that some of these may contain bufotenine, and in other cases we have no idea what they contain. So if you want to found a new field and have the tools, you can found psychoichthyology. There's a lot of work to be done here. So that's there to be done. And the effects are not trivial. The effects are definitely psychedelic, like one person described. It was pure science fiction. He ate one of these fish and had contact with alien beings and flying saucers and the whole shtick, you know. So, of course, there's the tetrodotoxin in the pufferfish, which Wade Davis has made famous in his book, The Serpent and the Rainbow, and the movie of the same name. Tetrodotoxin is definitely not a psychedelic, but it does have a strong effect in the sense that at low doses, sublethal doses, it will produce a paralysis that lasts about 48 hours in which you're completely paralyzed. You're also completely unable to move, speak, or anything else. And this is rather unsettling when they're discussing whether they should ship you off to the morgue or not, because you can't really raise a hand and protest. And this does happen. It happens occasionally in Japan, where fugu, the pufferfish, is a delicacy. And when I was in Japan a few years ago, I had a chance to try it. I'm still here, as you see, so it wasn't so bad. But occasionally they do screw up. They have specially licensed chefs that have to prepare the fugu so that the toxins are removed, the toxic organs of the pufferfish. Occasionally they screw up. I believe there are laws in Japan that a person suspected of dying from pufferfish poisoning can't be buried for at least 3 or 4 days. It's actually written into law just in case they might resurrect themselves. Frogs and toads, as we ethnopharmacologists know, are sources of bufotenine, and some of us are toad aficionados. Maybe we even have a little toad, what do you call them? Terrarium, I guess, a toadarium, where we can raise bufotenine-containing toads and obtain that substance from the glands, the venom glands of the toad, and smoke that, and that has an effect. Or sometimes it's 5-methoxy-DMT in some species of toads. You've heard undoubtedly about toad lickers in the media, but people don't lick these toads because they wouldn't be effective if they did that. In fact, it would be very dangerous because the toads also contain cardiac toxins, cardiac glycosides. But there are other psychoactive toads that are much less investigated. For example, in Peru, if you go down for an ayahuasca tour and you're bored and you've had enough of ayahuasca and you want to try something really far out, you can try the sapo, which is simply the Quechua term for frog. This one in particular, Philomedusa bicolor. It produces a compound in its skin secretions, and the way they apply it is they burn a hole in your skin and with a cigarette, and then they apply this, and you have a very violent, very fast, and rather terrifying effect where your blood pressure rises precipitously, you fall down, you're convinced you're going to die, you probably do come very close to dying, and then you recover from that and you feel great. For 2 or 3 days. And not only that, but you're superhuman. You can run through the forest, you can go on long treks, and you're tireless. I have not tried that. I haven't any intention of trying it, but some do, and I've never heard of a fatality, but I've heard of some that come close. Well, what's the chemistry involved there? Well, it turns out it's these deltorphines, these small peptides that actually hit another kind of opiate receptor, the so-called delta receptors. Opiates receptors fall into basically three categories: the mu, which is the morphine and those sorts of things hit, the kappa, which Salvinorin A hits, and the delta receptors. And obviously there's overlap. A lot of compounds hit all three or one or the other. They're not that selective. The opiate delta receptors have not been explored at all in terms of their psychedelic psychopharmacology. This is another promising area. These are hard to study because they're peptides. They're not small molecules, so they're not so stable. And then, of course, we've got the arrow poison frogs from Colombia primarily. These produce these very complex alkaloids. These are small molecules. They're alkaloids because they contain nitrogen. And they're very potent neurotoxins. They are channel blockers primarily, sodium and calcium and potassium channel blockers. So there's no psychedelic effect here, but they will reliably produce a near-death experience. The problem is it's a little bit close to the real death experience. So it's hard to study. But, you know, they're out there, and there are many different types of these types of things. Well, what about spiders? I don't know how many of you have ever seen the YouTube video, Spiders on Drugs, but it's a wonderful video, and it shows what great subject spiders are for studying psychopharmacology. It's a great behavioral model, and it's also kind of a spoof. Google that, and you won't be sorry. None of the spiders are psychoactive, but they can reliably induce, again, these near-death or real-death experiences, such as this one here. You know, and they work on these different channels, these different membrane channels, and glutamate, which is a neurotransmitter. So and glutamate is now emerging as very important in the pharmacology of things like schizophrenia. So spiders are worth taking a look at from this angle. We don't have any hot candidates, but somebody with the tools and spare time ought to look at this. Insects, another possibility, you would think, especially because insects have this long time association with plants, and they sequester plant compounds and do things interesting to them metabolically. You know, they take plant compounds and turn them into insect modified compounds. And in La Chirera, when Terence and I went down there and had our adventure, or our misadventure, whatever it turned out to be, one of our intuitions or understanding was that iridescent insects were indicators of the presence of tryptamines, psychotropic tryptamines in nature. And if we could just get these iridescent insects and grind them up, we'd have an experience. Well, we were preoccupied. We didn't really get around to that, but that was our idea. And so I did a little searching about what evidence is there for psychoactive insects in the literature? Well, not much, but after I looked almost 15 minutes, this is a long time to search the internet and not come up with anything. But I found this one, this article in the Journal of Ethnopharmacology, entitled A Pointer to a New Hallucinogen of Insect Origin. And it turns out it's the grub, it's the larval stage of this moth, which occurs in eastern Brazil. And the French explorer, Saint Hilaire, traveled in Brazil, and he reported that this moth, which fed on bamboo, so it's probably not coming from the plant, was consumed by the Malays Indians, I can't even pronounce it, a tribe native to the Brazilian province of Minas Gerais. And when the intestinal parts were eaten, it produced a fantastic dreams that lasted more than a day. So, needless to say, nobody's gone down there to check this out, but that would be worthwhile, and that's probably pretty easy to do. I mean, I guess the moth is still down there, unless they've eaten them all. So, you know, that also does raise the question of why do these psychedelic states, especially the states associated with DMT, why does the so-called tryptamine dimension that we explored at La Chirera and many others have explored since involve the seeing of insects? Why do DMT users see insects from a parallel universe? I don't really know. But there they do. Many people report this, and you don't even have to know about Terence McKenna, to see this. So it's not us that are disseminating this meme into the world. People discover this independently, and it seems to be a characteristic of the tryptamine dimension. Well, what about honey? That's another insect product that might be interested. Is there any evidence of psychoactive honeys out there? Well, as it turns out, this has been explored by our friend, our colleague, and the famous psychonaut Jonathan Ott, who may be here in the audience, and if so, thank you also for your experimental work. It's really an important contribution, and you've done it without benefit of research grants or anything else more than just a desire to, find out what's going on. He has written a very interesting article called The Delphic Bee, Bees and Honeys as Pointers to Psychoactive and Other Medicinal Plants in Economic Botany, 1998. He's always been ahead of his time. And according to Ott's article, the divinatory priests of Delphi were associated with bees, and the term soma and haoma, another term for soma, a Persian term, the term ambrosia nectar, were the sustenance of the immortals, and they may all represent allusions to psychoactive honeys of various sorts. We know that in the New World, the Mayans worshipped Muzan-Kab, I don't know how to say it, but the bee god. And Ott suggests that Mayan apiaries were initially established to produce psychoactive honeys containing nectar, perhaps from psychoactive morning glories containing lysergic acid derivatives. I don't think it's been established that the nectar does contain them, but this would be an obvious thing and very easily tested, and maybe Jonathan's done that. There are also toxic honeys reported from Colombia that have tropane alkaloids, which are not psychedelics, but certainly psychoactive and certainly shamanic substances. The other one that's kind of interesting is the mushroom shaman from the Salé to Salé plateau in Algeria. Everybody's seen this. Kat Harrison did the rendering of it, this shamanic figure with mushrooms growing out of its body and apparently holding clusters of mushrooms, but also wearing a bee mask of some kind. So what does that tell us? Maybe, and mushrooms and honey have long been associated with each other, honey being a great preservative for these psychoactive mushrooms. So maybe there's something going on there. Okay, so what about snakes? We certainly see a lot of snakes in the psychedelic experience, and if shamans learn about plants and medicines in the state, you'd think that maybe the ayahuasca especially is where you see the snakes. Maybe it's trying to tell us something. There's not a lot of evidence of psychoactive snakes, as far as we know. I encountered this gentleman on the Napo, and he was on our trip up the Napo recently, and he was proffering this as an important medicine. He didn't claim that it was psychotropic, but he did say it was muy fuerte, very strong, and that it would give you virility and long life and all that. And as you can tell, he's the picture of health. And he's just the kind, he just sort of makes you want to trust him, doesn't he? You can tell by his expression that this is a guy you can trust. I did try this material, actually. This is a snake pickled in aguardiente. And I took a tiny amount. I'm still here. I didn't feel much effect. Frankly, the aguardiente was strong, and I really wasn't willing to go any further. But I found a couple of interesting reports on snakes, again, thanks to the internet. Oops, I should move that back. A couple of reports. This one here, where heroin users could go to a place in India. This was originated in India, and they were admitted for detoxification of their heroin habit, and they described where they could go to a snake den, literally like an opium den, and they would deliberately be exposed to bites from cobras and other types of snakes, and this caused a euphoric effect, and followed by sleep. And there were a number of these snake dens throughout the Bombay area that were providing this service to these opiate habitués. So there's that. There's also a very interesting report on the dietary sequestration of defensive steroids by a snake which consumes a toad. And we know that the toad venom is a complex mixture of a whole lot of different toxins, class of which is the bufodienolides, which are these cardiotoxins. And so the snake consumes the toad, consumes the toad and sequesters these cardiac glycosides, and it's immune to them, but anything that eats the toad is presumably poisoned. And if it eats the snake, it may also sequester bufotenine. Most of these toads do contain bufotenine. So here's one of the most bizarre examples of sequestration in nature, one of the strangest examples of kind of a chemical symbiosis that I've ever heard of. Another interesting plant has come up, attracted attention recently. This is Mimosa hostilis, a member of the pea family that many of us may be familiar with. It's sometimes used as an admixture to ayahuasca if you can't get the usual admixtures like Psychotria and Diploteris. It's been known to contain DMT for a long time. Recently, reports, and it's the source of this traditional hallucinogen used in northeastern Brazil. It's an orally active preparation called urimeamine. It's kind of a dying practice right now. And it's also, as I say, used as an admixture plant in the presence of MAO inhibitors, either Paganum harmala or Banisteriopsis, to potentiate it orally. But now there are reports that are coming out that maybe Mimosa hostilis is active by itself. You just boil it up by itself and it works. Well, if it's only DMT, it shouldn't do that. Whereas the MAO inhibitor that's going to potentiate it. Well, it turns out, actually, again, we have to credit Jonathan Ott for this discovery. So what if it's not DMT plus beta-carbolines that's making it orally active? What is it? Is there something else in there? Well, it turns out maybe so. Jace Calloway in Finland and his colleagues just reported the isolation of this compound quite recently in the last year or so, which they named urimeamine after urema. And you can tell by the structure that it actually contains DMT in the molecule as a component of this larger molecule. And it's quite possible that it could be liberated, that it could facilitate its absorption across the blood-brain barrier or the intestines without an MAO inhibitor, and then be degraded into a form of orally active DMT. That's a possibility. It's also possible that urimeamine is an MAO inhibitor in its own right, or it may be a new hallucinogen in its own right. We don't know. But this is interesting. The chemistry's been done. We now need to focus on the pharmacology of this compound. We need to get a sufficient amount isolated in a pure form to do the large animal bioassay and see if it really does have an effect. Another interesting source of tryptamines are the acacias. As we know, I was recently invited to Australia to a conference, the Entheogenesis Australis conference, and there was a young man there named Jeremy Jones. I don't think it was his real name, but he presented a wonderful talk on the Australian acacias, which are known as wattles in Australia, and the Australian acacias are some of the most concentrated sources of DMT on the planet. Things like Acacia phlebophila and Acacia cortii, which are strict endemics, only occur in Australia and only in very restricted areas of Australia. They contain, sometimes they're up to 2% DMT in the bark and in the leaves of these things. That's a real high percentage for an alkaloid. It's generally about an order of magnitude less in most plants. It's high enough, in fact, that if you threw the leaves of the acacia on some hot coals and let it volatilize, you might actually get an effect if you were in an enclosed space. Well, it turns out the Aborigines, who claim they never use any psychoactive, no hallucinogens, they have other psychoactive plants, but they do have this practice of getting in a cave or in an enclosed area and inhaling the leaves of acacia. And if you look at Australian Aboriginal art, it looks pretty much like DMT. So that's interesting. Another, life's work in ethnobotany for somebody to figure out. Another area that's interesting, I recently had a grant. Don't ask me how I got it. I'm still wondering about that. But I got a grant from the Stanley Medical Research Institute, which is a private foundation that supports research on schizophrenia and bipolar disorder. And they're very interested in discovering new medications, and they're smart enough to know that ethnopharmacology has contributions to make here. So they gave me a grant. I mean, I applied for it, but they gave it to me. And I've been working on that for about the last 4 years, sorting through the traditional Amazonian pharmacopoeia. And on the side, or actually as part of this, we're doing a lot of receptor binding of these extracts. That's a quick and dirty way to look at how things in the extract might bind to different ranges of neurotransmitter receptors. It's a very easy assay. And we're focusing on 5-HT2A receptors. Why? Because it's a key receptor in the development of antipsychotic medications. And conveniently enough, it happens also to be the key receptor in the actions of psychedelics. So all these unknown psychedelics that Schultes has been writing about for years that are well documented through folk medicine, but chemistry is relatively unknown, are good candidates for the discovery of new psychedelic molecules. And you can screen them against the 2A receptors, and if they turn out to be antagonists, which then they're promising for the application as an antipsychotic, but if they're agonists, then they're promising potential psychedelics. Dr. Roth, the fellow that, the investigator that worked out the pharmacology of Salvinorin A, is my collaborator on this project. His group is doing most of the receptor screening. Well, we've come up with a few. We've collected about 150 different plant species down in the Amazon, and in the functional assays, the assays that tell you whether they're agonists or antagonists, we've come up with a dozen or so that have pretty good action at the 5-HT2A receptor as serotonin agonists. These may be the new psychedelics of the next 10 or 15 years that are going to be giving the authorities fits for a long time as they try to figure out how they're going to control these ones. On the receptor binding level, the different type of assay, we also came out with a list of plants that seem to hit these receptors quite well, quite potently at low concentrations. Interestingly enough, few of the plants on this list are identical to the plants on this list. So what does that mean? Well, we're not sure, but these are two different ways to characterize the 5-HT2A active constituents. And then using that simple bioassay, you can use that to guide the fractionation. You can fractionate these extracts into different parts and test each one and eventually get down to what the chemicals are. And that's how it's done, the old bioassay-directed fractionation approach. So, there's a whole list of things here that might potentially be psychedelic that few of us have ever heard of. But we better get cracking, because these compounds, these plants, are being prohibited even as we speak, sort of the preemptive prohibition. This notion of the criminalization of nature, this idea that, well, these things are out there, and these things might potentially be dangerous to our children, and we can't have that. So we have to make lists of these things, and we have to make them all illegal before anybody gets into any trouble with it. God forbid that anyone should, have an experience that, with one of these unknown plants. So they're quickly developing laws. There was recently a law passed in the Louisiana legislature that listed a number of these unknown, unwell-characterized hallucinogens. Some of them are familiar to us. Some of them are known and are known to be active. Others are virtually unheard of, even by botanists, But on the off chance that some of them may be hallucinogens, they figure they better get busy and make these things illegal. And so, at least in LA, if you're busted with, a couple of kilograms of Omedio parabea sclerophylla, you could go to jail. And, I can just imagine the scene down at the station house. Hey, Jack, we just brought this guy in with, 5 kilograms of what? And I wrote to this gentleman before the law was passed, and I pointed out the difficulties that he would face in even identifying these plants. You need to hire teams of botanists and teams of pharmacologists, or pharmacognosists rather, and teams of chemists to even determine the identity of these things. But this, of course, didn't occur to this moron. And I never got any reply. And unfortunately, a side effect of this is the prohibition of these plants also prohibits the research, the legitimate research that might come out of the discovery of these new molecules and these, for their therapeutic use or their use in research and so on. It just makes the whole thing much more ridiculous. And if anything points up the futility and the absurdity of the war on drugs, so-called, or what's really a war on plants, this is it. I can't believe, the stupidity of the person that brought this bill to the floor and the legislators that went along and prohibited this. Well, of course, weird things go on in Louisiana. We know this. Surely this would not be done on the federal level. Don't be so sure. It's not so clear. Again, this goes back to what I was talking about earlier, our attitudes toward nature, our notion that we own nature, we can patent it, we can exploit it, we can destroy it, we're not part of it, and we're perfectly within our rights to patent any damn thing we see out in nature and prohibit whatever else we don't like. And that's a dangerous attitude, and that's where we're going with this. And I think, mercifully, that's the last slide. Thank you very much.